And today we will be discussing the power dissipated by the resistors. Let first of all take the example of a 2 ohms resistance. There is 2 ohms resistance and we have 6 volts battery. So we have to first of all determine what current flowing through the circuit. It is 2 ohms and it is 6 volts. So the current by Ohm's law, V is equal to IR, and we are getting I is equal to V by R, and V is 6 volts, 2 ohms, and it's 3 ampere current. Now, what is the power of a appliance? Power of an appliance is the energy dissipated by a resistor per unit time. Per unit time. So we have power is equal to work done by time. This work done is also voltage into current by time, VI by T. Am I saying it correct? Nah, I'm not saying it correct. It's work done. So we are having, it is wrong. It's totally wrong because we are having voltage is equal to work done per unit charge. So we want to have the work done. So W is equal to VQ. So how can this I came? But yeah, I will came but T will not be there. So P will be equal to VQ by T. It's V dot Q by T. And as I told, charge flowing by unit time is current. So it will be VI. And the energy of the circuit, the energy that is used by that appliance or the resistor is VI by T. It's the energy. It's the energy used by the appliance. And we have usually the questions of the power. And we have energy, that's the commercial unit is kilowatt hour. And you should remember 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. It's joule. And we have learnt it in class 9. So there's nothing to be discussed. Now what is the current flow by him? It's 3 ampere. So the power is 6 volts into 3 ampere. It's 18 watt. It's watt, 18 watt. And if we are given the time that it is used for 1 hour, then the energy dissipated, it will be 18 into 1 by 1000, as we have to calculate in kilowatt hour. It's kilowatt, and 1 kilowatt is equal to 1000 watts. 1000 watts. So it will become 0.08 watt. Oh, sorry, it's 0.018 kilowatt hour. This is the energy dissipated, and you can say it's 18 or 1.8 into 10 to the power minus 2 kilowatt hour. Similarly, you can calculate all in series and parallels, the powers and energy dissipated. And there is nothing discussing about it, and 2 short topics are there, overloading and short circuiting. But the main difference has confusion. What is the difference between overloading and short circuiting? Suppose you are having a socket, and from one socket you are charging your phone, charging your laptop and other things like geysers, working on induction, using your iron, all from one socket. So the current passing through it will be very high as they are all in parallel. So this large amount of current will produce a large amount of heat, and this will cause overheating, and this will burn your socket, and then it will cause fire. And short circuit, we have 2 wires, light and neutral. If they touches each other, it touches at that point, then the current flow from light to neutral will be very high, as the resistance is very low. so the very high current will pass through it, and this extreme current can cause extreme heat at the point, which will cause it to burn, and burning, and then it will cause to fire. This is overloading and this is short circuiting. You should know that MCBs nowadays work on electromagnetism. It works on electromagnetism, not on heat properties of a resistor. Heating effect of electricity can be also known as Joule heating effect, and this is used by the fuses. There is a safety device fuse where there is a thin wire in an enclosed circuit and current flows through it. If current flows through it, it melts and breaks the circuit. It breaks the circuit, and breaking the circuit will cause not fire. And MCBs for here is a coil, and I will be talking in the next episode. As large current flows, large magnetism appears, and due to high magnetic property it will close the circuit as let it be plus, and there is a gap, and there is a pin like switch, which is caused due to over electricity flowing through it, as let take this and take this, and this be neutral, and let there be a short circuit as they have touched here. This is a short circuit, and a large current will flow through this coil, and large magnetic effect will cause, and this will break the circuit as there will be a gap, and there is a lever like system which will lock it at that point. When it is at this extreme point, it will lock it, and until we switch on with our manually switch on this, it will not turn on, and the circuit will be broken, and there will be no risk of fire. Thank you. That's all of your electricity chapter, and it has ended. You may go and take some fun and come again, and I will be next talking about the magnetic effect of electric current.